Hello, and welcome to MVAO 102, Introduction to Auto Operator Rules. This is Part 2. MVAO 102 is the second in an 8-part series of courses covering MainView Auto Operator. When beginning to build out your automation using Auto Operator, one of the first things to consider is what your automation strategy will be. The automation strategy controls which rules will be fired in which rule sets. There are 3 possible values we can specify for our automation strategy. The first is first, which says, Auto Operator, I want you to scan your rule sets, and when you find a match, stop scanning. So we're really only going to fire one rule at any given time. If we specify a strategy of all, that says to Auto Operator, when you find that first match, keep going until you get through all of your rules, and then I want you to execute all of your matches. And then the third type of automation strategy is individual, which we'll talk about later. Let's consider how these automation strategies impact the execution of our rules. So here you can see we have a message, IEF 403I, with the job name of ABC and a type of STC. Over on the right, you can see we have a series of rules in 2 different rule sets. So we're going to take a look at this. If our strategy is first, what's going to happen is Auto Operator is going to begin with the first rule in rule set 1. Well, in this case, it happens to match the message. So at that point, Auto Operator stops scanning the rule sets and executes whatever the action criteria is for that rule. Now, if we specify a rule set strategy of all, the behavior is a little different. Auto Operator will still match that first rule in the first rule set, but then he'll continue scanning looking for additional matches. And you can see they're highlighted in red that we have 2 rules in rule set 1, as well as 1 rule in rule set 2. And those will all be executed. The preferred rule set strategy for Auto Operator is individual. And what individual says is I want to have independent rule set strategies for each of my rule sets. In turn, those rule set strategies can be either first or all, which we've already discussed. So this allows us to do some things that can be pretty interesting in Auto Operator. So let us consider our message again, and this time we have a strategy of individual. And if you look over on the right, you can see rule set 1 has a strategy of first, rule set 2 has a strategy of all, and rule set 3 has a strategy of first. So let's consider that we get our message IEF 403I, and Auto Operator is going to begin scanning in the first rule set. He says, oh, this rule set strategy is first, so when he encounters the first match, the IEF 4 asterisk, he's going to stop scanning in that rule set, even though the next rule would match as well. So then he goes down to rule set 2 where the strategy is all, and he starts scanning through those rules. Now in this case, when he finds the first match, he continues scanning, looking for additional rules in that rule set that match. And that's because he has a rule set strategy of all. And once he finishes getting through rule set 2, he continues on to rule set 3. And rule set 3 has an automation strategy of first, just like rule set 1. So what's going to happen here is Auto Operator begins scanning the rules, looking for matches. Once he finds one, he stops scanning. Now I'd like to take a few minutes to talk about some of the various Auto Operator solutions. The first I'd like to talk about is Auto Operator for CICS. Auto Operator for CICS allows you to trap messages that are written to the CICS transient data queues. Not all CICS messages are written to the console, and there can be important messages that are missed if you're not monitoring the TD queues. Now, Auto Operator for CICS provides you with the ability in rules to trap messages that are being written either to the extra partition or intra-partition TD queues. You also have the ability to directly issue CICS commands, and you have access to all other AO actions such as issuing alerts or querying or setting variables. For support within execs, we have the ability to issue CICS commands and interrogate the responses. We can run CICS transactions and pass parms. And we also have the ability to collect data from MainView for CICS using the MainView interface in Auto Operator. It may be desirable to limit the amount of traffic that is being exposed to AutoOperator from the TDQs. We do provide you with a vehicle to limit that data by assembling a CAODTAB macro, and it supports parms that allow you to limit the data to either include or exclude your extra or intra partition queues, as well as specific queues themselves. Now, the general idea is you really don't want AutoOperator to process all the data that's going to the TDQs because there can be a lot. And if there are certain messages or queues that you want to monitor, it's best to specify those. And we do provide you with a sample job to show you how to assemble and link the CAOD tab macro. It's in the BBSAMP library member DTABJCL. Let's walk through building a rule for a CICS TDQ message. In this case, we're going to consider message DFHAC2236, and it's written to the CSMT TDQ. So when we go into AutoOperator and we're building our rule, if we want to do something for CICS, we're going to specify an event type of CICS, which you can see specified in the middle of this display. In the selection criteria screen, we'll specify the message ID that we want to trap. We can optionally specify the TDQ, and then we can specify a job name or a CICS region. So in this case, we're looking for message DFHAC2236 on TDQ CSMT, and it needs to be in a region that starts with C, followed by any character, ending in GA. In the action specification screen, here we can specify CICS commands that we want to issue. But in this instance, what we're going to do is we're going to issue a message to the console indicating that this transaction has failed again. Let's take a look at AutoOperator for IMS. AutoOperator for IMS uses two exit points in IMS for AO. There's a type 1 AO exit routine, DFS AOQUE0, and a type 2 exit routine, DFS AOE00. Within the rules, AutoOperator for IMS provides you with the ability to trap IMS master terminal messages. You can issue IMS or IMS Plex commands. And of course, you have access to all the AutoOperator facilities, such as using the journals and setting query and variables. Within execs in AutoOperator, you have the ability to issue IMS commands and interrogate the responses. You can run IMS transactions and pass parameters. And you also have the ability to collect data from MainView for IMS using the MainView API in AutoOperator. Let's take a look at automating a master terminal message, DFS 551I. This is a message that gets generated whenever a dependent region gets started in IMS. It could be a batch region, a fast path region, maybe it's host JVMs, or it's a message region. If you want all the additional detail for this message, please reference the IBM documentation. For our purposes, we're going to trap it, and then we're going to issue a command in response. So here we see the first screen in our rule definition, and we specify an event type of IMS, and you can see that in the middle of this display. And then for IMS, all we need to do is specify the text ID for the message we're trying to trap, DFS 551I. And in the action specification screen, here we're going to issue an IMS Plex command /query space IMS Plex. And it's really just that simple. Another AutoOperator solution is AutoOperator for MQ. AutoOperator for MQ supports queue managers that are either local on MVS or non-MVS queue managers. If you want to automate non-MVS queue managers from AutoOperator for ZOS, then you will need to define the queue managers in the distributed environment via sender-receiver channels. And if you want to trap the events, then you will need to reroute the events to a local queue where the MVS queue manager is. Okay, now there are two types of events that we can automate on. We can trap event messages, which are the MQ format events. If you want to see all of the different event types that are supported, you can put a question mark in the field and we'll provide you with a list. I have an example of that in a slide or two. We also can automate on non-event messages, which are generally messages on a queue, and those will show up as user messages on the event screen. AutoOperator for MQ gives us additional capabilities in the rules processor. We have the ability to trap messages written by MQ. We can issue MQ commands directly, and we have access to all the other AO actions, such as alerts and variables, so on. Within execs, we have the ability to issue MQ commands and solicit responses. We can use the MQ API to do gets and puts of messages. And we also have the ability to use the MainView API to collect additional information from MainView for MQ. So here's the selection screen that we'll see when we want to build a new rule. And in the middle, we've specified an event type of MQS. Now remember, if you don't know what those values are, you can put a question mark in that field and press enter, and you'll get a list of all the possible values. In the selection criteria screen, here we specify what the queue manager is that we want to trap the messages on. We specify the format of the messages, so what type of event is it, and then the actual event type. Now, if we place question marks in some of these fields, we'll get some additional information which can be helpful. So here's an example of what we will see if we put a question mark in the format field. And here we list all of the supported formats for the events. And when we place a question mark in the event type field, we'll get a list of all the possible event types. If we browse on one of the types, then we'll get some additional information as well as the variables that are associated with that event. So coming back to our rule, here we can see the action specifications for our MQ message. And what we're going to do is we're going to issue an MQ command, and we're going to capture the variables that have been passed in from the event. And we're effectively going to set the high event, the queue depth high event, to enabled for that queue. This concludes MVAO 102 Part 2.